Hi, welcome back to Bexhill West. I'm James. Now in today's video we're going to be talking about 3D printed model railway track using Templot software. Now I've hinted at this for the last couple of videos. If you're not familiar with Templot, it's a marvellous track planning or track design piece of software designed by Martin Wynn. Now the topic of Templot in itself could expand over many videos, so rather than introduce Templot specifically here, I'll refer you back to a video I made a couple of years ago. Now that video is not particularly up to date, and I made it when I was just sort of coming to terms with Templot myself. However, if you've not used it before, that will serve for now as a good starting point to show you what it's capable of doing. Now just in a nutshell, just to save you leaving this video and going and having a look at that one, Templot enables you to design templates for hand-built track. Now the problem with hand-built model railway track is it requires some skill to assemble. You traditionally need quite a selection of typically quite expensive gauges and jigs to produce the various components. Now when you're really skilled with it, the truth is you don't really need half the jigs and you can make do with very few gauges. However, there is a barrier of entry in terms of having to get hold of the equipment to be successful with it. What Templot allows you to do is to produce 3D printed timbering bases and the chairs to hold the rail. The whole system clips together, you don't need any gauges at all, and where you do need special jigs to file the V's on different pieces of rail, Templot will produce the files so you can 3D print those jigs also. Now behind me I've got a couple of examples of 3D printed track produced using Templot. Using standard nickel silver rail, steel rail would work just as well. I guess you could even 3D print the rail if you really wanted to. But for now, and for this video, we're going to focus on 3D printed timbering bases and 3D printed chairs to take commercially available rail. Now, there are a couple of ways of producing the timbering bases. We could do these as a 3D print produced using a filament printer or FDM printing, or they can be laser cut from plywood, and Templot will give us the CAD files that we need to do either. Now, certainly for the smaller gauges, Templot recommends resin printing for the chairs themselves, and there are a number of options for the chairs. You can have chairs with solid jaws, you can have chairs with a loose outer jaw that clips in separately. We'll look at those in a bit more depth later on in the video. But basically Templot gives you complete freedom to design whatever track you want in any gauge or scale, and best of all, you can 3D print the parts. You don't need any specific CAD skills or CAD software to do it. Templot produces all of the files ready to sort of plug straight into the printer. So this video is going to be a quick run through just to sort of show you how simple the process can be. The number of controls and options in Templot is really quite vast, and if I were to cover all of them, this video would become too long. So for this video I'm just going to focus on producing a length of plain track using clip fit rail chairs. Now this is quite straightforward and I'm going to whiz through it hopefully fairly quickly. When we get to the end of the process, I'll show you how that process can be refined, so watch the video to the end. I'm going to keep turnouts as a separate video, so that my next video will be looking specifically at turnouts, and some of the techniques that we use in this video, if it gives you a chance to practice them for when the turnout video comes out in a couple of weeks time, and you'll be able to apply those. Turnout's a little bit more complex than plain track, so let's sort out the plain track first and then we'll deal with the turnouts. Anyway, enough wittering on from me, let's get on with the demo. I have on the counter here an example of an FDM printed timbering base. We can see we've got 3 lots of rail, and these are joined together with little splints so that these things can be assembled and laid as a unit. Now it's worth taking a close look at the timbering base, and it's unlike perhaps commercially available track systems in as much as the edge of the sleepers are joined with like a web, and the purpose of that web is so that if we wanted to, we could pin this down through the web. These webs of course will be hidden under the ballast, so you'll never see them. Doing it this way also presents opportunities to run the wiring for the rails above the baseboard rather than underneath. In fact, the next Templot update I believe will have a little modification made to it which will simplify that, but we'll save that for a future video. Now here's a chair raft as an example of some of the chairs, and let's show you just how easy they are to fit. So we can skewer them with a cocktail stick, cut them away from the base. I've not even touched this with my fingers, and then that chair will just plop in wherever we want it to go. So in this case I'm going to put it here and it will just snap in. There we go, it's as simple as that. So we could drop these chairs in, as many as we like, build up the track panel, there we go. Now you may well see that the outer jaw isn't on here. That's because these particular chairs take a loose outer jaw that clips in, and if we have a look over here, these are all clip-on loose outer jaws. We'll look at those in a bit more detail later. So to produce the length of plane track, let's fire up Templot, and as usual Templot greets us with a line of curved track with the turnout placed in the middle of it. Because I want to produce a plane track template, first thing I'm going to do is change the gauge by clicking, I was a bit quick there, clicking this little bit here. I could choose gauge off the top menu, but let's click here where it shows the default gauge of T55, and I'm going to change that to S4/P4 because that's the gauge I'm working with today. So let's change the gauge of our track. If I click the plane track button at the top of the screen, that will transform that into a length of plane track, but it's still curved. So if we go to the geometry menu at the top of the screen, I can click straight, and that's given us a length of straight track. And we can look at the scale on the bottom of the screen and we can see it's just over 750 millimeters long. Now that's going to be far too big to fit on the bed of my 3D printer, so I'm going to make this shorter. So we can do that with the length button at the top of the screen. When we click on it, it tells us that it's actually 800 millimeters long. If I left click and drag the mouse, I can adjust the length of this to whatever I like. Let's set it to 250 millimeters. So I can just drag that down with the mouse, or where the measurement is displayed there, we can click there and we can enter a precise measurement in. Click OK. Now it's possible to connect lots of these little templates together. So if we wanted to make a yard of track, we could divide it up into smaller bits that we can fit on our printer and join them with little connector clips. We'll look at those in a future video, but for now here's our piece of track. Now handy tip is to hit the little blue dot up there, and that zooms it in so we can see what's what. Now we need to tell this that we want to 3D print it, we need to chair it, and for that we need to turn on the experimental chairing feature, and that will be found in the Reel menu at the top of the screen. Chairing 3D, and if we scroll across to the right we can select experimental chairing and left click that. Gives us a nice little page to read. We'll ignore that just for the time being, and there we go, we're presented with our control template with all the little chairs drawn on, and the experimental 3D box has turned up. Okay, at this point we're not going to worry about the chairs, but that's pretty much ready to go. So, but before we can consider 3D printing this, what we need to do is store the control template into the kind of virtual storage box, and we do that by hitting the two orange arrows up the top here, and that will copy the control template into the background track plan. When we've done that, we know we've done it because it highlights the thing in green. Now the thing that's in green, well, let me show you what's happened here. If I click Shift and Join, hopefully you can see what happened. As we stored that first template, it stored it into the background, it's coloured it green so that we know that it's stored, and it's created a new control template. So we could play around with this one and make ourselves another template if we want, but I don't want to do that for now. For now we're going to export PL001, which is our first template. So to do that, very simple, we click DXF/STL file export. We want timbers only, so we select that box and make sure the little blue check mark is there, and then export the file. Now we need to give this file a name. I'm going to call it 250mm track panel. Hit save. At this point, Templot is going to prompt us to mesh fix. Now we'll talk about mesh fixing in just a minute. It's going to do that using something called 3D Builder, which is a piece of software which you may already have on your computer at home, but be unaware of it. If not, you can download it, and we could click that top button there where it says Get 3D Builder and download it. As I've already got it downloaded, I'm going to click Open STL file, and when we click that, Templot's going to do something really clever for us. We'll click Continue once more, and what it's going to do is open the 3D Builder software and in it place ready for us to use our timbering base, which is pretty good. If we're happy that that's the right one, we can click Import Model in the top left, and it will almost certainly tell us that this needs repairing, and it's highlighted in red. And to repair or mesh fix, we click this little spanner icon in the bottom right. Now an STL file is comprised of lots and lots of triangles, hundreds of them, that all have to be connected in a particular way, and it's very easy for that file to become slightly corrupted. The mesh fixing process just repackages them all and gets it ready so that it's a nice solid model. And there we go. Now at that point, Templot does another clever thing for us in that if we hit the save button, or the save icon here, click Continue, that's automatically going to save that into one of the Templot folders on the C drive. It's going to save that into a folder called STL files fixed. We'll look at that in just a minute. And that's all there is to it. That's taken me several times longer to explain than it actually takes to do in reality. So we can now get on with creating the 3D printer file. Let's do that now. Right, I'm now into my 3D printer's slicing software, and this is called Cura. Cura tends to be shipped with most 3D printers. The great thing about Cura is it's also freely available to download. So if you Google Cura, you'll take you to their website, you'll be able to download this. Even if you don't have a 3D printer, you'll be able to install this on your computer and have a little play with it. So let's go to this icon in the top left called Open File. And because I've been using this in this session already, it's already defaulting to the folder that I need. Had it not have done so, I could have clicked on, in my case, Windows C drive, selected the Templot dev folder and the STL files fixed folder. And there we can find our 250mm track panel. So I'm going to select that one, click Open, and that's placed that on the screen for us. And we can, we can zoom in, we can move this around, we can do all sorts of things. But that's basically what it's going to print. Now the square area represents the build plate of the 3D printer, and it's worth knowing the size of that of your machine to make sure that each little section or little template that you print will fit on your machine. If need be, we can click on the part and we've got controls. So for example, we could rotate this round a little bit, let's say at 45 degrees, and that's quite a useful way of fitting more onto the bed of your machine. Now down here in the bottom right, we can see it's already sliced the file. In fact, I'm going to do that again. I'm going to click over here, I'm going to change this ever so slightly, and watch the bottom right hand corner of the screen as I come away from it. You can see it's automatically sliced that file. That's now ready. We can save it onto a little USB stick or an SD card, put that into the front of the printer and press print. Now normally my printer is connected via a USB lead to my computer, and in which case that would give me the option down here in the bottom right just to print directly. Now that's all I'm going to say on that for now, but I'll just mention all of these settings above. These are all individual settings which comprise the print profile, and we can change things like the layer height and infill density and stuff to optimize the print characteristics for the part that we're making. I'm not going to talk about that for now because it will complicate things, but in part 2 of this little mini series where we look at turnouts, I'll run through the Cura profile in a bit more depth and point you towards some useful settings. So at that point we can save this to file, we can decide where we want to save it. We could save it into, for example here, 3D print files, click save. In your case you would probably save it onto a USB stick. Okay, let's consider the chairs next. Now before we get into looking at the chairs in detail, let's talk about the chairs just broadly first of all. So the rail chairs are the big cast iron lumps that connect the rails to the sleepers or the timbering. Now prior to sort of the railway grouping, all the different companies had different ways of doing the chairs. Some of them had 2 bolts in, some of them had 3 bolts, some of them had 1 bolt and a wooden dowel. I mean, there's all sorts of different ways of doing it. And in 1922 the Railway Engineers Association, or REA, specified a standard range of chairs to take a British standard 95 pound per yard rail, designated 95R. So this was the standard rail section and a standard set of chairs with which to build the track. Now I mention all of this because Templot produces plug track components to REA specifications, and this is sort of worth knowing because if you want to produce a, for example, Great Western 9-foot loose-heeled switch for a turnout, Templot won't be able to provide you with the plug track components for it. You'll certainly be able to design it in Templot, you can design whatever you like in Templot, but it currently only produces plug track for REA specification components. It's hoped that Martin will at some point be able to program in chair components from other companies and what have you. So stay tuned, that could be a future development, but for now it's just REA components, and it's important to know that when you sit down to have a play with it. So then let's have a look at the chairs, and we'll return to our screen, and if you remember, this is the template that we use to produce our timbering base. Now above it is that second control template that was automatically generated. We're not going to do anything with that just for the minute. I'm going to come back to this template, select it, and then come over to the left here and make the control. So we've now made this the control template, the one we're working on. Now in terms of the chairing, there's one thing really we need to do first of all, and that's decide what sort of chairs that we want to produce. Do we want solid jaw chairs with 2 fixed jaws, or do we want the type with a removable outer jaw, a loose outer jaw? Now that's the default, but what we're going to do is we'll come back up to the top menu where it says Reel and Chairing /3D. This is the one we visited last time. Let's come back down here, just where we clicked experimental chairing, just below there we get chair jaw options on this template. So I'm going to select that choice and we'll be presented with this box. Now, if we want to export our chairs with solid outer jaws and keys, then we would simply click that box, and that's all we would need to do. Click Apply Changes. However, in this case, I want to have a solid inner jaw and loose outer jaws. So what I'm going to do is select the top option, which is Export all chairs with slots for loose outer jaws. So that's going to just give me the chairs without the second set of jaws. That'll all make sense in a moment. I'm going to click Apply Changes, and it's highlighted this template now to say we've got some jaw slots. So now I can come to DXF/STL file export, and I'm going to click chairs only for resin printing. Now I've got the complete set of menu options here because I've been having a play. The chances are when you open this up you'll just see this part of the menu, and this is all you need to export. But if I click show settings, there's all sorts of other settings. We'll look at those in the next video, but for now all we need to do is chairs only, and just as before click export DXF/STL. So what I'm going to do is, let's call it 60-foot track panel chairs. Save. And it's going to prompt us just as it did before. Do we want to mesh fix these? So we're going to go through the same process. I'll go through this quickly, but just show you there are our chairs. If we zoom in, you'll be able to see the slots for the loose outer jaws. You'll see the plugs, and you'll see it's generated some support. Now we're going to talk about that a little bit more in just a moment. Let's click Import Model, just as we did before for the timbering base. It's highlighted it in red. We'll click the spanner icon and wait for it to do any repairs that it needs to do to the file. And when that's complete, we'll save it. And just as before, it'll save that automatically into the folder, the Templot folder called STL Files Fixed. Now, the chair file's a lot more complicated than the timbering base, so it does take longer to repair. And so with the file repaired, we can click the save icon. Now at this point I want to open that up into my resin printing slicer. So let me open that up. So the resin slicer is called Box. Again, that comes standard with most resin 3D printers, and again you can download this piece of software separately from actually purchasing a machine, so you can play with this to your heart's content. Now I've got a number of printers programmed in, if you like, or set on here. This is the present default, which is that little Alcade printer that I showed in my previous video. So if I go File, Open, and what I'm going to do is search through my computer, click on the C drive, Templot _dev, STL files fixed, and 60-foot track panel chairs. Click Open, and there we are. And we can zoom in and have a look at these things. They look magnificent. We can rotate these things around, but we're going to immediately see a problem in that as they've become exported from Templot, they just simply don't fit on the sort of the working space of the machine. It's extending out both left and right. So what can we do about that? Well, quite a lot actually, and in fact I'm going to show you an efficiency which, if we master this next skill, will come in really handy when we move on to onto turnouts, sorry. But basically that's all we need to be doing. We would click slice the program would slice it all for us and give us a file ready to print. Now it's telling us that the model extends from the perimeter of the available space, so I'm not going to do that now. I'll continue with the demo and we'll take us back into Templot and we'll look at how we can condense these things down so we can get lots and lots of chairs printed in one go. So I'm back in Templot, and below we've got the template that we've been working on. Now we've got this top one here, PL002, which if you remember is a copy of our original. So what I'm going to do now is I'm going to select that one and make it the control. Now what I'm going to do is use the length tool that you'll remember we used previously, and I'm going to drag this down so we've got just one sleeper. And whilst we're at it, let's zoom in a little bit so we can look at that in more detail. Now that's 18.83mm gauge. Of course we're printing just the chairs, so it doesn't really matter what that gauge is. In fact, there's some advantage to reducing that gauge. So what I'm going to do is come up to gauge. I'm going to come down the bottom here, modify current settings, modify track gauge. And we can change that gauge to whatever we want it to be. I'm going to make it, let's say 10. Click enter. Okay, so that's reduced the gauge. We probably could have made that a bit smaller, but not to worry, that will do. Now, having done that, if I come back over to this 3D menu that popped up previously, if I click Shift and Store Multi, what that's done is it's duplicated everything for me a convenient number of times. So now when I go through the export process, I'm going to get all of those chairs bunched together and they will fit onto the bed of the machine. But Templot allows us to go one better than that. So what I'm going to do now is create a raft. I'm going to do that by going Shapes. Let's give this shape a name. And we're going to call it raft. Now the next thing we want to do is tell it that it's going to be a rectangle, and we can enter that by drawing a raft, by entering dimensions, or putting it at the clicked locations. Let's do it by drawing. I'll click Add Shape. Now I'm just going to move this box out of the way, and we can now click and drag a rectangular shape around those chairs, and you'll see a red line has appeared indicating where that shape is. Let me zoom in here. Hopefully that's a little bit clearer. Okay, I'm going to repeat now very quickly the process I went through before. So I'm going to go in fact, no, I'm not. What I'm going to do, so I'm going to delete that template. We don't need that one anymore. So I've just got this one here. So what I'm going to do now is click DXF/STL file export, just as we did before. I'm going to go chairs only, and what I'm going to do is go to show settings, and if we have a look, there's all sorts of menu tabs at the top. If I click chair plugs and sockets, we can choose whether we want clip fit, snap fit or press fit chairs. I'm going to keep it on clip fit just for now. That's the default. If we look at supports, we've got some options here, and by default the 3D rectangle shape will become the chair raft. So I've not changed anything. Let's click export. Let's call it 60-foot track panel chair raft. Save, and just as before, this is going to prompt us to mesh fix. And if we have a look now, conveniently all of those chairs are now condensed onto a little raft, and we can 3D print them in one go. Now this is very convenient, especially for plain rail chairs or S1 chairs, because we're going to need lots and lots of those. Now it's worth also noting, if we have a look at this raft, Templot has also kindly provided a little undercut on the edges, so that when you've 3D printed these things, you'll be able to get a little scraper tool underneath it and prise it off the bed of the printer. Now, I won't run through this process and make you wait for the whole thing, but basically this will repair, we'll save it just as we did before, and then I will open it in Chitubox and you'll be able to see the result. So now I'm back in Chitubox. I've opened that file, exactly the same thing as we did previously, and you'll see that we've got 2 rows of 13 chairs all neatly compressed onto a single raft. Now what I can do is, using the copy button in Chitubox, I can make several copies of that, and there you go, we've got over 100 chairs now all ready to print. Now if I click the slice button and we slice all of that, it'll tell us that those 100 chairs are going to cost us just under 31 pence in resin, and it's going to take 31 minutes to print them. At this point I could click save, at which point I would save it onto a little USB memory drive, and I could put that straight into the side of my 3D printer and click print. And half an hour later we'll have 100 S1 chairs. Of course we can keep repeating that process and we can print as many of these as we like. So that's the process for producing S1 chairs for plain track. So there you go, that's a quick run through of the process involved in producing plain track, and it's actually much quicker and easier to do than it is to explain. So if that process seemed a bit long-winded, trust me, by the time you've been through it 2 or 3 times, you'll get the hang of it and you can simplify it and speed it up considerably. Now, in the next video we'll look at turnouts, and as I said at the start, they're a little bit more complex. But bear in mind that Templot gives us sort of infinite freedom on how we design the turnouts, what hand they are, what gauge, scale, angle, what type of switch, etc, etc. Now, there's a bit of understanding that we need to have around turnouts and some of the sort of the prototype principles, so we're going to cover those in the next video. Now, before we get onto that, let's deal with a couple of questions which I know are going to come up in the comments. Firstly, is this expensive? Well, firstly, no. Templot itself is free, and Martin Wynn, who writes the software, it's his hobby. He produces it for fun for himself, and he allows others to make use of it. So it costs you nothing to experiment, basically. Next question is, do we need to buy 2 3D printers? Ideally yes, but they needn't be as expensive as one might initially think. So for example, it's no coincidence that my last video reviewed the cheapest 3D printer that's currently available, I believe, in the world, and certainly in the UK. So in the UK that's £90 delivered. I think it's about £82 plus a bit of postage. And all of the resin printed chairs that you've seen in this video were produced on the world's cheapest 3D printer. So although that's quite an expense, it's only roughly equivalent to about 2 filing jigs for traditional track building systems. You're likely to invest more than the cost of a 3D printer in producing the gauges and the tools required for track building traditionally. Of course, once you've got the 3D printer, you can then use it for all sorts of other things. Now, the FDM printed base does require a second 3D printer. It requires an FDM printer. And you can use pretty much any FDM printer will produce exactly the same results. So it could be a second-hand one, or better still, I think, would be to get together as a club or find somebody you know who's got a 3D printer and share. If you've got a resin printer and your mate's got an FDM printer, you could share the workload between yourselves. The actual cost of the filament for the FDM printer or the resin itself is, I'm not going to say nothing, but it's next to nothing. It's almost not worth worrying about. So producing the parts is considerably cheaper than if you were to explore any other commercial route. So for example, I think you could build a really impressive, completely prototypically realistic turnout for probably less than £2 for all the materials. Well, contrast that with what you might pay for a ready to sort of lay example from somewhere like Pico or Hornby, and you'll realise that that's quite a saving, with the benefit that the turnout that you produce is prototypically accurate. So I think that's enough wittering on. If you've got any more questions, do please leave them down below. It'll be my pleasure to try and answer them. Hopefully others from the Templot Club will pitch in and help answer questions. And bear in mind that all of this is available, and the support available from the Templot Club website. But please don't bombard Martin with questions on there, because I want him to carry on programming the software and inventing new bits for us to play with. So let's not swamp him with too many questions just yet. Okay, so till the next video, have a play with this. I think you'll enjoy the system and have great fun using it. Thanks for watching. Cheerio.